Hello, everyone. I'm Dr. Dave Thomas. I'm an astrobiologist at Lyon College. I'm also a volunteer solar system ambassador with NASA's Jet Propulsion Laboratory. And today I just want to talk a little bit about the upcoming solar eclipse and how to view that safely. So, an eclipse is actually a period when the moon is perfectly aligned between the sun and the earth. And this casts a shadow on the earth. Now, like everything else, it really depends on your location as to what you can see. So if the three planetary objects there, or celestial objects, the sun, the moon, and the earth, are not completely aligned, then you may get a partial eclipse like we see here. And we had one of these just this past October. If the earth is, or excuse me, if the moon is a little bit farther away from earth than its average is, then it doesn't quite completely blot out the sun, and we get this annular eclipse here. Now, if everything lines up perfectly and the sun and the moon and the earth are all at just the right distance from each other, then we get a total eclipse where the entire disk of the sun is blocked by the moon, and we get to see the sun's corona all the way around here. And that's what we're going to be able to see here in Arkansas during the upcoming eclipse on April 8th. Okay, so this is from NASA, and it shows two eclipses here. We have the October eclipse, all right, and it was an annular eclipse even for those who are directly in the path of totality here. So if you were in basically the desert Southwest, you got to see that whole thing. Over in Arkansas, we got to see it as a partial eclipse, but for the upcoming eclipse here, we are going to be right in the path of totality here in Batesville. And so we will get right around 4 minutes of totality in the early afternoon. Okay. Now, this gives some of the local areas here. So the closest one to us is Little Rock. All right. They're going to have a totality being at 151. Up north of us in Poplar Bluff would be at 156. So ours is supposed to start around 152, 153, somewhere in there. Okay, you can find some of these other cities that might be closer to you to find out when you might be able to see it. Okay, so here's the partial eclipse of October 14th. It actually turned out that most of Arkansas was under overcast weather. I decided I was going to go fishing that day and happened to luck out that the clouds got thin enough that I actually did get to see it. And I was able to take some pictures of that. Okay, now, regardless of whether you're looking at a total eclipse, a partial eclipse, an annular eclipse, wherever it happens, before you get to totality where the sun's completely blocked out, there's still enough sunlight to permanently damage your eyes. So never, never, never look at the sun without proper eye protection. All right, and you need to have things that are specifically made for viewing the sun. Now, for the glasses, and this would also be for things like welding helmets and things like that that also have dark glass, they need to meet this ISO 12312-2 standard. And that just, it's a reference of opacity and how much can go through there. Now, this is written on glasses that meet this standard, but this can also be counterfeited because there's nothing to prevent an unscrupulous salesperson to actually make these things that aren't up to standard, but print that ISO number on it anyway. You can go to this website that's put out by the American Astronomical Society, and that will actually tell you where there are reliable dealers that have truly approved glasses. Now, if you look at the illustration over here, some of these people are not using glasses. They're using basically a postcard-like solar shield. It does the same thing, but this may be more effective if you already wear glasses like I do and have trouble getting the solar glasses over your other glasses or under your other glasses. Okay, regular sunglasses, it doesn't matter how dark they are, how much of a mirror finish they are, they're not enough, you're going to damage your eyes. Okay, now if you are in a total eclipse, not an annular, not a partial, you can take your eye protection off during the period of totality because the sun's completely blocked at that time. Okay, now, many of you may want to use a telescope or binoculars or a camera to view the eclipse. All right, make sure that those have filters on the front lenses, the objective lenses. You don't want to be wearing your solar protection glasses and then put an unprotected lens in front of that. What will happen is the sunlight will burn through or melt your sunglasses, and then you're going to have concentrated sunlight hitting your eyes. Okay, and that will do permanent damage in a fraction of a second. So you don't want that. So telescopes or binoculars shown here, you can get solar filters that are specifically made for these devices. The same thing for cameras. Now, if you have an indirect observation camera, okay, where you're looking at a screen and not directly through the eyepiece. So basically anything that's not an SLR, single lens reflex camera, those you got a little bit more leeway with, but again, concentrated sunlight can damage the sensor of your camera. So it's still best to do that. Although in my case here, I took this shot without it because there were enough clouds there. But if I were doing this with a single lens reflex and suddenly that cloud got a whole lot thinner, I could have really damaged my eyes. So this was taken with an indirect viewing camera. Okay. You may want to take pictures of this. Now, if you're not using a dedicated camera like an SLR or something else that has its own filter, you can do this with a camera phone by taking one piece of a set of glasses, solar eclipse glasses, cutting that off and just taping it directly over the lens of your camera. Okay, make sure that it's on well enough. This one's kind of popping up with the tape here. You don't want this to accidentally come off. You won't blind yourself with it, but you might permanently damage the camera sensor. Okay, also you want to make sure that you keep that camera up in front of your eyes and that you're not accidentally looking around. Okay, you can also view this indirectly. And if you've seen an eclipse before, you may have noticed that say if you've got sunlight coming down through the leaves of a tree, you can see the image of that eclipse everywhere that little light spot happens. Down here in the lower left, this is showing the same type of effect through a colander. So you could actually just hold a colander out, look at its shadow, and everywhere there's a hole in that colander, you're going to see a little bit of the eclipse. Back in the late 1970s, when I saw my first eclipse, we didn't have these inexpensive solar glasses, and we use these indirect types of viewing things. This is simply made out of a box. You put a white piece of paper or cardstock here in the opposite side of the box, cut a hole in one corner, and then cover that with aluminum foil. And then you take a pin or a needle and put just a single tiny hole in that aluminum foil. And essentially you make what's called a pinhole camera. And that will project the light of the eclipse onto your screen here. And then you have another opening on the other corner here that you can look through and watch that screen. Okay, and this actually does give you a pretty good view of the eclipse. The longer your box is, the larger this image will be, but it'll also be dimmer. So you want to let your eyes adjust to the light a little bit before you try and actually figure this out. But this way, the sun's always behind you, and so there's no chance of you accidentally looking at the sun with this. Okay, now, if looking at that schedule I showed earlier, the eclipse actually goes for about a total of 3 hours from partial to full to partial again. And if you're going to be out in the open during that time, keep in mind that most of the time you've got a lot of sunlight hitting you. So dress for the sun as well. Have a protective clothing on, sunscreen, a hat, whatever you would normally use to protect yourself from sunlight. Okay, so to recap this, all right, always view the sun through eclipse glasses or a handheld viewer that meets the proper standards for that. Okay, only, there we go, only look at the eclipse when the moon is fully covering, so during totality. All right, when you can't see any part of the sun through your eclipse glasses, then that's the safe time to look at it. Okay. And then as soon as you see even a little sliver of sunlight appearing, put your glasses or your viewer back on. Okay. And with that, you can't ask me questions directly, but if you do have questions, I can be contacted at david.thomas@lyon.edu. Have a great eclipse, everyone.